We are going to do a t-test for dependent means. So you're going to want to open up data set 12.1. So chapter 12, data set 1. And we're going to do another 4-step problem. So we're going to use our plan, our state, plan, solve, and conclude. So under our statement, we're just going to use our data and make a statement. So we are looking at a data set that is comparing the post-test to the pre-test, looking at different score values. So if you have not opened that up, go ahead and do so. And I'm not entirely sure what this data set is representing, so we are going to just make it up, and we're going to say that we believe that the mean post-test score will be greater than the mean pre-test score, which would make sense. If you're taking a post-test, usually you're assessing prior knowledge. Chances are you do not have a lot of prior knowledge, so your pre-test score you would expect would be less than a post-test after you have learned the material. So let's create our hypothesis based off of this, and we're going to have our null and our alternative. And our null states that there is no difference between the two. So I'm going to say the mean of the post-test is going to be equal to the mean of the pre-test. And I'm just kind of abbreviating here. So my null states that there is no difference, that both groups scored very similarly. What we're actually testing is that the mean of our post-test going to be greater than the mean of our pre-test, because we think that after they've gotten some studying done and different things like that, they should do better on that post-test. Now on to our solve step, and we'll do our solve step over here in SPSS. So you should have a data set that looks something like this. If not, reopen it. So to calculate this, to analyze, we're going to analyze and compare means, and we are going to use the paired samples t-test, which is the comparison of two dependent means. A paired t-test is, I think, a more common way that it's called, either paired t or matched paired t's. So you're going to click on this and you're going to get a little bit different dialog box than we did for the two-sample t-test. We want to drag, since we're looking at post-test being bigger than pre-test, I want to put post-test in as my variable 1, and I'm going to put my pre-test in the variable 2 spot. So I'm going to take my post-test and subtract my pre-test. So the paired t-test works in a manner that it takes the first variable, subtracts the second variable, and determines if the difference is positive or negative. If you have a positive difference, that tells you that variable 1 is bigger than variable 2. If it's negative, then variable 1 was less than variable 2. At least that's, in theory, what you should be looking for. So we're going to click OK. And you're going to get an output very similar to this. Obviously, we've got a lot of information again. But what we are looking at here is obviously our last paired t-value. So they give you all the different information about each test. So if you're looking at mean, sample size, standard deviation, that first box gives you your descriptive statistics. Now let me find it here. So now if we're looking down here at our paired sample t-test, which to me is your more important one anyways. There we go. I'll make it a little bigger. While we're looking at this, that mean is the difference. When I take my post-test and subtract my pre-test, that is the difference between the means. So that tells me on average that my post-test average is 1.2 times, or 1.2 bigger than my pretest. So if I take my post-test, subtract my pretest, on average I'm getting a difference of 1.2. The exact probability that a t-test was obtained by chance is our p-value, which is our significance over here, our 0.022. So obviously that tells us that that is a one-tailed test or two-tailed test. We actually want to figure out the significance of a one-tailed test. We want to figure out that the first group is bigger than the second group. So to do that, you need to go to the back of your book, Appendix B, and find table B2. So you might want to take a minute and do that. You're looking at table B2, and if you're wondering, that's on page 372 of your textbook. We find that for a one-tailed test, and we want to look at our degrees of freedom, which is 24. So in table B2, which actually starts on page 371, but we're going to look on page 372, and you want to use our degrees of freedom, which we found was 24. They calculated that for you. And we're doing a one-tailed test of 0.05. Okay, so you want to go over the degrees of freedom row that says 24 and down the column that says 0.05, and you're going to get a value of 1.711. Okay, so since our value from our table is actually less than our t-value, because we had our degrees of freedom of 24, so we got a 1.711. Since our value from our table is less than our t-value, then since our t-value actually exceeds our critical value from our table, then since our obtained value is greater than our critical value, we cannot accept our null hypothesis, we can reject it, and we can accept our alternative. So in this situation, since our t-value of 2.449 was greater than our critical value, I forgot that was 1.711 or whatever it was, since our t-value was greater than the value in the table, then we can, let me double check, get 1.711. So since t is greater than the 1.711, we can reject our null and accept our alternative, which is that, and I'm just going to go back, conclude, and you can copy and paste that in there if you would want, but we can, since our t-value is greater than our critical value, and you could write those values in, but we can reject our null and accept our alternative hypothesis that the post-test scores are greater than the pre-test scores. Okay, I want to show you something else though with this. If we were just looking at, is there a difference? So instead of testing greater than, we're testing there is a difference. We could go back over to this and look, and then we would just use our p-value as they give us, which is that 0.022. Now if you notice, that's less than 0.05, so that also tells us that there is a difference somewhere. So since the 0.02 is less than 0.05, then we can reject our null and accept our alternative that there is a difference in the data. So as you know, SPSS only gives us if there is a difference. If we're actually trying to test greater than or less than, then we need to use that table in the back of the book there to determine if our t-value actually exceeds the value in the table. If it does, then we can reject our null and accept our alternative. If our t-value is less than that critical value, then no result or no conclusions can be drawn.